morning, everybody. So as we know already in last class, we studied what is Newton's second law of motion, and we have been derived the derivation for Newton's second law of motion. That is what F is equals to ma based upon our textbook. Is it yes or no? What the book which I have given to you guys. So and we have been found that last class. So force F is equals to, it is a product of two things, that is what mass into acceleration. Same way mass and acceleration both are inversely proportional to each other. Is it yes or no guys? Or else we can say acceleration is equals to force by mass. So force is directly proportional to mass, force is directly proportional to acceleration, but mass and acceleration, how the relation? Hari? Mass and acceleration inversely proportional to each other. So this is what we have been found in the last class. Is it yes or no, Mitakshri? Any doubt in that, Akilan? Now, in our today's class, once again, we are going to study the same thing, but in a different manner. Now, you can see Newton's second law of motion. As we know, it will give you the relationship between what, guys? Anybody can tell? Newton's second law of motion will give you the relationship between what? Force and acceleration. Understand? So that is what we are going to learn once again. So it will give you the summarize the Newton's second law of motion. So if you notice it, when we are applying the greater force, larger the force, greater will be the change in momentum. Smaller the force, lesser will be the change in momentum. That is why we can say the rate of change of momentum of a body is directly proportional to the force acting on it. Is it yes or no, Hari? Yes, ready? So whatever the change in momentum of a body is depends on the amount of force which we are applying. If you are applying more force, more momentum or less momentum? More force. More force.
More momentum.
More momentum. Less force, less momentum. That is what. So Newton's second law of motion will gives you what is the relationship between this force and as well as change in momentum. We used to call something. What is what we used to call as? What is that? Acceleration. Understand? So that is what. So it will give you the relationship between force and acceleration. Now, let us discuss according to the Newton's second law of motion. As we know in the last class, we already written F is directly proportional to first formula. What you have written? Tell me. See in your notebook and tell me. Force is directly proportional to change in momentum divided by time taken. Yes or no, guys? Yes, please. So force is directly proportional to, we have been written that change in momentum divided by time taken. Is it we have written or not? Gokul, Danishka? Yes, please.
Yes, sir.
Yes, sir.
Remember, change in momentum means, I said you in the last class already. So change in momentum. Anybody can tell me what is the symbol of momentum? Danishkar will say, others you will be silent. Change in momentum. Arun Kailash, what is the symbol of momentum? Symbol of momentum. Anybody? This is what you people are studying. I am asking symbol of momentum. Momentum can represent with what letter?
P, sir.
P. That is what I am asking. Symbol means that is only correct. You people don't know that? P. So that is what change in momentum means. I told you one point. What is the change in momentum formula? Mitakshri? Change in momentum is equals to what? Final momentum minus
Initial momentum.
that is what. So final momentum minus initial momentum we can say. So this is what we studied. Is it yes or no? Now, if it comes to here also the same thing we are going to do. So force is directly proportional to change in momentum by time taken, which will represent in mathematics way. F is directly proportional to delta P divided by delta T. This is the symbolic representation of momentum. We will write force is directly proportional to delta P divided by delta T. So this is the different way. So what do you mean by delta? This is what we used to call as delta. What we used to call? Delta. So which is indicating change. Do you understand, everyone? So that is what you have to remember. So delta P, how to read this one, Hari? delta P divided by delta T. This is what change in momentum. That is what only we used to call as Newton's second law of motion. Now, observe very carefully. So, derivation of F equals to ma, if you have been taken. So, as we know, you can keep heading derivation of F is equals to ma. So, let us discuss how this derivation is to come and what we have to do it. Now, consider a body is having initial momentum something. So, that is what we have to do it. Consider a body is having initial momentum. Initial momentum we represent with some letter. You just check it and tell me in our notebook, previous notebook. Initial momentum P1. And is it a vector quantity or scalar quantity? Is it a vector quantity or scalar quantity? What here? Nobody is answering. Momentum is a vector or scalar quantity?
Vector.
That is what I am asking. What happened to others? If people don't know, momentum is a what quantity? Means nobody is writing the notes. That is what I can understand. If not interested, leave from the meeting. No issues. Momentum is a vector or scalar quantity?
Vector quantity.
Maintain the notes. That is what. So vector quantity means we have to represent with the direction. What do you mean by vector quantity? What do you mean by vector quantity? Anyone?
Magnitude and direction.
Magnitude and as well as it must be having direction. That is what. Hey Danishkar, if not speaking, leave from the meeting. I will say to father also. No problem. Everybody I am saying you. No issues. So a body is having initial momentum. Let consider a body is having initial momentum P1. That arrow it is indicating what? It is the vector quantity. Now let us momentum change to P1 when a net force F is acting on the during the time interval of delta T. Do you understand? Now let change in momentum. Let change in momentum. How it will change? P1 to what will change? Final momentum. How we can represent? Change in momentum is P2. Understand? P2 in a given period of time. In a given period of time. So period of time, how we can represent? Just now we have been represented. Period of time, we used to represent with what symbol? Delta T. That is what. Okay. That is what you have to remember. Now, change in time, delta T in momentum is equals to. So it is what the net force is acting in a given during interval of time. That interval of time we are considering as delta T. So now if you notice it very carefully, so that change in momentum only we used to call it as change in time, delta T in momentum is equals to, we used to call it as, what is the change in momentum? Anybody tell me the formula? Change in momentum. Change in momentum in delta T time, which is equals to what is that? P2 minus final momentum minus
Initial momentum.
minus initial momentum. That is what change in momentum. Yes or no, Kaushik? Gokul? That is what. Now, change in momentum in unit time. What is the change in momentum in unit time? Change in momentum. Change in momentum in unit time. Unit time means delta T, which is equals to change in momentum divided by change in time. Is it yes or no? Hari? Change in time. Okay. Now, change in momentum in unit time, this is what we can say for applied force. That is what we can say net force. So force is also a vector quantity or scalar quantity. Force is also a vector or scalar quantity.
Vector quantity.
Vector quantity. That is why we have to represent with arrow. So delta F is equals to, if you'll notice it here, understanding. So as we all know that, then I can say the formula P2 minus P1 divided by delta T. Now, you tell me, final momentum means, what is that? Last class we have been considered. For example, I will consider the car is moving now. So its initial velocity is u, mass is constant. So after certain period of time, mass is same, but final velocity is v. Now, what is the momentum of this case? Anybody? Before momentum, initial momentum, what is that? Initial momentum is what?
MU, sir.
M into
MU.
final momentum is what? What is the final momentum? M into V. Now, in place of P2 and P1, can I replace with this? Yes or no? Everybody?
Yes, sir.
That is what? You have to speak. That is what I'm saying. So I can say rate of change of momentum only we used to call as understanding force. So we can say P2 is equals to mass into understanding final velocity and P1 is equals to mass into initial velocity. So velocity is also a vector or scalar quantity. Vector or scalar
Vector
quantity.
quantity.
Vector quantity.
So we have to represent with arrow or not? Metaxi?
Yes, sir.
That is what. So we have to represent with the arrow. That is what initial velocity and final velocity. So I can say change in momentum. That is what rate of change of momentum. Rate of change of momentum. That is what we can say force, which is equals to, I can write, what is the formula? You tell me. Final momentum, mass into final velocity minus mass into initial velocity divided by delta t. Is it okay, everybody? Yes, please.
Yes, sir.
Yes, sir.
Now, as we know that something is constant here. What is that constant in this? So we can say
M.
M equals to M is constant. Let me take M is separately. I can say final velocity minus initial velocity divided by delta t. Is it yes or no, guys? Yes, please respond. Now, please tell me. Change in momentum I can represent with a delta p. Delta p is equals to final momentum minus initial momentum we have taken. Same way, final velocity minus initial velocity also we can represent in the form of change in velocity. How we can represent? Anybody? That is what we can represent as m into, can I represent delta v, change in velocity? Yes or no, Hari? Yes, please respond. So delta v divided by delta t, that is what we can say. Change in velocity we used to call one thing. Anybody can tell what is that called as change in velocity?
Acceleration.
Change in velocity, what we used to call? We used to call it as acceleration.
Final velocity.
Yeah, acceleration. Here all proportionality. I am keeping equals to sign, but you are not at all telling me anybody. So it is proportionality only. So, yeah. Tell me, Hari.
Sir, we can keep K, sir, constant of proportionality.
Constant of proportionality. We can keep it at last we have to keep it. Now, we know that delta V, change in velocity divided by delta time, change in time, which is equals to something. What is that, guys? Which is equals to what? Acceleration. So acceleration also vector quantity or scalar quantity. Vartini, Mitaksri, Vartini not speaking. No issues. I don't have any problem. Okay, what is that? It is also a acceleration is also what?
Vector quantity.
So I can say force is equals to mass into acceleration. Is it yes or no? Yes, that is what.
Yes, sir.
You can see from Newton's second law of motion, we have been concluded that F is directly proportional to, I can conclude, M into delta V divided by delta T. Now, as we know, delta V divided by delta V means what? Anybody? Delta V means what? Change in velocity. Do you understand? Change in velocity. That is what you have to remember. Kaushik, are you understanding? Change in velocity. Same
Yes, sir.
what we did in last class. So now if I want to remove this proportionality constant, then I have to bring something equals to sign. What I have to do in mathematics? F is equals to, what will come? Proportionality sign
Constant.
equals to constant into mass into acceleration. That is what will happen. Now, as we know, according to the SI units, what is the K value? So unit of
One.
force in such a way that it produces unit acceleration in a body of unit mass, then we can say the constant proportionality K is equals to what, guys? K is equals to what? 1. Okay, that is what. So, sir, why sir 1? That is what now I will explain. Listen, what is the unit of force? Unit of force what? What is the unit of force? Newton.
Newton, sir.
Yes or no? So 1 Newton is equals to something. Can anybody tell 1 Newton is equals to something which we already studied? 1 kilogram force, kilogram meter per second square. Yes or no? Which is equals to 1 Newton. Yes or no? Ready? Hurry. Danishka,
Yes, sir.
that is what. So that is why we are considering K is equals to 1. Why means, remember, what is here, the logic behind is a unit of force is chosen. Please note it down. Unit of force is chosen in such a way that it produces unit acceleration in a body of unit mass. That is what you have to remember. Understand? It produces what? It produces unit acceleration. What do you mean by unit acceleration? One meter per second square. Do you understand, Ra? Unit acceleration in unit mass. Unit mass means how many kgs? Unit mass means, please respond. Unit acceleration in a body of, understanding, in a body of unit mass means 1 kg. So that is why K value will become what? So that then the constant of proportionality, K is equals to what? 1. Do you understand? So that is what you have to remember. Constant of proportionality. Everybody note it down. Is it okay, Reddy? Clear? Gokul, Arun Kailash?
Yes, sir.
That is what. Okay. So please, all of you make it. So this is what? Force. So K is equals to 1. So we can say F is equals to what, guys? Mass into acceleration. Okay. This is what it is. Any doubt till here? Ask me. So Newton's second law of motion establishes that an unbalanced external force is required to accelerate the body. So that is why we can say a force is a vector quantity or scalar quantity, guys. Force is a vector or scalar quantity.
Vector quantity. Vector quantity.
Why it is vector quantity? Anybody can tell? Because if you want to accelerate the body, is it possible to accelerate by itself or external forces need to apply?
External force.
External forces need to apply. So it is always applied in a particular direction. That is why we can say force is called as what? Vector quantity.
Vector.
That is what. So if you want to see the movement in a body, then we need a balanced forces or unbalanced forces. Anybody? Balanced or unbalanced forces? If you want to create a motion, if you want to stop a moving body, if you want to make a body to move, you need balanced or unbalanced forces. That is what I'm asking. Navi full disturbance Navi video motto ada sound. Video sound. If you'll notice it here, so finally we have been made a formula. That is what Newton's second law of motion. That is what force is equals to mass into, what is that? Acceleration. So now if you'll see, this is what Newton's second law of motion always will give the, always gives relationship between whom? Relationship between mass and as well as acceleration. Okay, so or else we can say force and as well as acceleration. So how that force and as well as acceleration is dependent, and what is that relation between them has been Newton's second law of motion gives us that relation, force and acceleration. Now if you notice it here, as we know already the known units of force, which we already knows that, what is the unit of force, guys? Unit of force, which we already knows that, that is what we used to call it as Newton. That is what we can say SI unit. And same way we all people knows that CGS unit also. What is the CGS unit, guys? What is CGS unit? Dyne. Okay. I understand, guys. So already we know that the SI unit of force is what? Newtons. And what is the CGS unit of force, guys? CGS unit of force is what? Dyne. Yes or no? Hari, can you hear me, Hari? Akilan? Now,
Done.
let it be till now, all the people knows that this is what
Yes,
S
sir.
dyne, and this dyne is the CGS unit. But of course, before going to separate this SI and CGS unit, now we will separate the units of force into two different kind of units, which to called as, that is what we used to called as absolute unit, and the second one is called as gravitational unit. What is the units of forces? We're having two types of units. One is called as absolute unit, and the second one is called as what? Gravitational unit. Okay, so now all of you keep heading units of force. Units of force. Shall we start now? If you'll say yes, we'll continue, or else.
Yes, sir.
Yeah, now, so we're having two kinds of units, please remember. So two kinds of units we're having. That is what one kind of unit is called as absolute units, and the second one is called as gravitational units. What is that, guys? Absolute units and gravitational units. Now, these, let us discuss now first absolute units. So absolute units are again two types we can make. One is SI unit and another one is what? CGS unit. Okay. Now, if you'll notice it here, absolute unit of force in SI system, that is what we used to call as in SI unit of absolute unit of in SI system of the force. What is that called as, guys? Everyone? That is what we used to call as, yes, please, is called as
Newton.
what? Newton. That is what we used to say Newton. So as we know, 1 Newton is equals to, we can write it. What is the formula of Newton? Anybody? 1 Newton is equals to 1 kilogram into 1 meter per second square. Is it yes or no? This is already we people knows very well. From the long back, I'm teaching even chapter 1. Whenever we can get Newton, we people can write kilogram meter per second square. Yes or no? Yes, please. The same thing I am doing here. So,
Yes, sir.
in SI unit, absolute unit of in SI system of force is Newton. So 1 Newton is equals to 1 kilogram meter per second square. Now, can anybody explain this in the form of theoretical? What do you mean by kilogram meter per second square? So what is like 1 Newton, 1 joule and all we have defined in the first chapter. What do you mean by this? Anybody can tell? How much force is applied? If 1 Newton force is applied and how much mass, Hari? On 1 kilogram of mass, then if it is produces 1 meter per second square acceleration, that is what we used to call as 1 Newton. Do you understand it? Now, we can say if 1 kg of mass is accelerating 1 meter per second square, then we can say the applied force is equals to how much, guys? What is applied force? Which is equals to 1 Newton. That is what. So please all of you write that. Everyone. 1 Newton is the force. 1 Newton is that force. 1 Newton. 1 Newton is that force. 1 Newton is that force which acts on a mass of, which acts on a mass of how much, Mitaksri? Mass of how much? Everybody. Mass of
1 kilogram.
1 kilogram. Mass of 1 kilogram and produces an acceleration of how much? And produces an acceleration of 1 meter per second square. That is what we used to call as 1 Newton. So it is which unit, guys? What is a Newton? Is a which unit? Absolute unit. Understanding? Absolute unit in which format? SI system. That is what it is. Next, CGS unit. You already people know. I already taught you. What is the CGS system of absolute unit of force in CGS system? That is what we used to call as. What is that called? Anyone? Nobody is answering. What is that called? Dyne. What we used to call? That is called as dyne. Then write absolute unit of force. Absolute unit of force. Absolute unit of force. In which units, guys? In CGS system. Now, what do you mean by CGS? Anyone? Arun Kailash? Kaushik, what do you mean by CGS? What do you mean by CGS? I'm asking.
Centimeter, gram.
Harish, you silent Harish. Let them say they'll know or don't know. Otherwise, leave from the meeting. No issues. I'm saying very, very seriously. What you are all playing here with me? Simply sitting and going from here. What do you mean by CGS
Sir,
system?
centimeter gram per second, sir.
Centimeter grams.
So, CGS system is dyne. D-Y-N-E, dyne. So, we know that one dyne is equals to already, one dyne is equals to what will come? Anybody can tell? Instead of kg, here what I can write? 1 gram. Instead of meter per second square, I can write what, guys? Same meter. So we can say 1 dyne is equals to 1 gram into 1 centimeter per second square. Is it yes or no, guys? Same way, like 1 Newton is equals to 1 kilogram into 1 meter per second square. So, but here we are writing 1 gram into 1 centimeter per second square. Is it right or wrong? Yes or no? Yes? Akilan, now you define, anybody can define what do you mean by 1 dyne? Anybody can define what do you mean by 1 dyne, please? Anyone can say 1 dyne is that force. What is that? 1 dyne is that force. Yeah, is that force is applied on how much? Force which produces an acceleration of how much, guys? Which produces
1 centimeter per second.
one produces an acceleration of 1 centimeter per second square in how much mass? In a body of mass? 1 gram. In a body of mass, 1 gram is called as 1 dyne. Please all of you write. A body of mass 1 gram is called as 1 dyne. So 1 dyne is the force. If applied on a 1 gram of mass, then if it is produces 1 centimeter per second square, then it is known as 1 dyne. Any doubt in this? Ask me. Mitaksri? That is what. Write it. Clear? Yes, please.
Yes, sir.
Yeah. Now, keep reading. All of you. Relationship between dyne and Newton. Shall we see the relation now, everyone? Are you ready? Okay. So now, this is what? So this is already people know, somebody of you. So one Newton is equals to how many dynes? 1 Newton is equals to how many dynes? Nobody. That's fine. I will teach you now. So relation between Newton and dyne, you keep it ready. What is that? Relation between Newton and dyne. Shall we start now? No.
Yes, sir.
Yeah. So we already know that 1 Newton is equals to how much, guys? Anybody tell me the formula? 1 Newton is equals to, we people know already. What is that? 1 kilogram into, what is that? 1 meter per second square. That's all. If you know this, then we can find what is the relation between Newton and dyne. Now, we know 1 kilogram is equals to how many grams? Anyone? 1000 grams. Same way,
1,000 grams.
1 meter is equals to how many centimeters? 1 meter is equals to how many centimeters?
100 centimeter.
Is it any other thing? That's all. Arun Kailash, no response. Don't join from tomorrow. Strictly, I'm saying. I'll say to mother also. No problem. Now, 1 kilogram is equals to, in place of kilogram, can I write it as 1,000 grams? Yes, please. Now, same way. In place of 1 meter, what I can write? In place of 1 meter.
100 centimeter. 100 centimeter.
Per centimeter square. Sorry, per second square. Nothing it changes. Now you can see. 1000 into 100, I will write separately. Is it right or wrong? 1000 into 100 separately, I'll write. And gram into centimeter per second square, I will write separately. Now you can notice it. 1000 into 100, I can write in the form of powers. Anybody tell me how I can write powers? 1000 I can write as a 10 power 3 into 100 I can write as a 10 power 2. Yes or no? 100 means I can write 10 into 10. Mithakshi, have you understand? 1000 I can write as a 10 into 10 into 10. Is it right or wrong? Everybody. That is what? Gram to centimeter per second square. 10 power 3 into 10 power 2. What is that mathematics? You all people knows, which is equals to 10 power 3 plus 2, which is equals to how much, guys? 10 power 5.
10 power 5, sir.
That is what. So 10 power 5
Temper 5.
to centimeter per second square. So this is what it is. Now we know already one dyne is equals to something. What is that? Tell me. One dyne is equals to 1 gram into 1 centimeter per second square. Is it yes or no? Yes, please. So now in place of this one, can I write as a
Yes,
one
sir.
dyne? In place of this one, can I write as a dyne or not? That's all. That is what. So 10 power 5 dyne, which is equals to how many newtons? How many newtons, guys? 1 Newton. So this is what the relationship between
1 Newton.
and dyne. So people, even most of them, they don't know how it came. But some people will learn 1 Newton is equals to 10 power 5 dynes. But how it is coming, you have to know. So 1 Newton is equals to how many dynes? 10 power 10 power 5 times. That is what. So Reddy, have you understand derivation? How to convert it? What is the relation between Newton and dyne? Kaushik, solve it now. Everybody solve. Any doubt, ask me. This is what it is. So now, if I have solved this, this is what is this? All absolute units or gravitational units? Absolute or gravitational unit?
Absolute unit.
Absolute unit. Now, second one is gravitational unit. Okay. Yeah, please keep it. Gravitational units of force. Gravitational units of force. So again, here also, which unit? 2 units will be again. One is what? One is SI unit, and another one is what, guys? CGS unit.
CGS.
Okay. So now, SI unit of gravitational unit of SI system. If you notice it, all of you observe here very carefully. SI system, if you notice it, the unit is kilogram weight, or we can say kilogram force. What is to call? What is the unit? Kilogram weight. Understand? Or we can say what? Kilogram force. Is it okay, guys? So representation is very important. See here how I am representing. kgWt, like this we have to represent kg and subscript wt. This is what kilogram weight, or we can say kg small f, that is what kilogram force, not normal kgf. Understand it? Kg small f, okay, down subscript, that is what kilogram force. Okay, same way if it comes to CGS system, gravitational unit of force of CGS system, if you notice it, which we used to call gram weight, or we can say gram force. What we used to call? Gram weight. Okay, so which will represent with like this, small g and wt, or else we can say gram force. How we can represent? GF. Is it okay, Mitakshri? Tanishka, late, always late. You cannot be in time.
Yes, sir.
10 minutes break in middle. Arun Kailash, have you understand or not? This is what? Gravitational units of force. In which units, guys? Gravitational units. Absolute unit is over. This is called as gravitational units. So in SI system, we used to say kilogram weight or kilogram force. In CGS system, we will say gram weight or gram force. This is what it is. So now everybody note it down. Now, 1 kilogram weight is equals to, please note it down, 9.8 newtons. 1 kilogram weight is equals to how many newtons? 1 kilogram weight, understanding, which is equals to how many newtons? 9.8 newtons. This is what it is. Same way, 1 gram weight, which is equals to 980 dynes. 980 80 dynes. This is what both relation you have to remember. What is this relations? SI, absolute units and gravitational unit. The relation between absolute and gravitational unit, that is what the relation. 1 kilogram weight or 1 kgf also we can say. Okay, that is also you have to remember. 1 kilogram force or weight is equals to 9.8 Newton. Same way, 1 gram force is equals to 980 dynes. Is it okay, everybody? Miss Vartini, simply sitting, attending a meeting and not even writing the notes also. I'll check the notes in this offline class, I will see by that time. Those who are not writing the notes offline class, I'll check it. Then you can talk. So that is what. So 1 kilogram weight is equals to 9.8 Newtons. 1 gram weight is equals to 980 dynes. That is what is the relationship between absolute units and gravitational unit. Any doubt, guys? Till here, please respond. Yes? All of you? Are you clear? So this is all about what is Newton's second law and what is the derivation of Newton's second law and what is the units and the relations of units Newton's second law. Any doubt, guys? Please respond. Now, the next concept which we are going to study, that is what we are going to study applications of Newton's second law. But before going to study the applications of Newton's second law, now we are going to study the one more very important concept for yours. That is what? Impulse. What we are going to study now? Impulse. Understand? So that is only very, very important.
Impulse.
And let us see what is this impulse and what is the formula and what is the important units and all. IMPULSE, impulse. Please all of you keep reading. IMPULSE, impulse. Okay. Shall we discuss now what do you mean by impulse? Everybody, are you ready? Yes?
Yes, sir.
Listen very carefully.
Yes, sir.
What is impulse you understand. Later you can learn one more word called as impulsive force. What is that word? Impulsive force. Okay, so both we'll discuss now. First you understand impulse, later impulsive force is very easy. So listen, when a sharp knock is given to a door, for example, you might be noticed, then you can see what is the momentum there. If I hit the door, I have given a sharp knock to the door, then what is the momentum here? Who is giving the momentum? Who is touching the door? That is what the momentum it will get. The moving finger has momentum. Yes or no, guys? When I'm hitting the door, my hand is keep on moving. So that who is having momentum? My hand is having the momentum. Yes or no? Yes, please respond.
Yes, sir.
Yes. Now, once the door is stuck or the momentum of the finger is reduced, so that, do you remember? It is reduced to 0 in a very short interval of time. So you can see, as a result, the force is imparted on the door in a very large, in the short interval of time. Then we can see our finger will get hurted. Is it yes or no? Yes, please respond. Yes.
Yes, sir.
So suppose if you are hitting the door normally, our hand cannot be hurting. But if you are trying to hit it with a very like a sharp knock, then within a fraction of second, our finger is going to come into the 0. Yes or no? The rest. So like a karate person, he is trying to break the very big files of tiles within a single shot. How he is making single shot he is trying to break? Because huge amount of force he is applying and piles of tiles, if you notice it, within a fraction of second, momentum become what? Momentum become 0. Do you understand it? Because within a fraction of seconds from the extremely high force is applied and for velocity become what? Velocity become what? 0. If velocity becomes 0, momentum becomes 0 and that force is passing towards to the tiles so that all the tiles will break. Same way, when you will notice the door now, if you are within a fraction of second, if you hit it, if you have given a sharp strike, if you have given a sharp strike to the door, then within a fraction of second, the velocity of the finger or the momentum of the finger will become zero, so that it will exert huge amount of force within a short interval of time, so that our finger will get injured or not. Your finger will get hurt or not. Will you get pain or not? Please respond. Yes? Nobody is saying.
Pain, sir.
Yes. So that is what. So the large force acting in a short interval of time, that is what we used to call as impulsive force. What we used to call? What we used to call? A large amount of
Impulsive
force.
force.
Large amount of force is acting in a huge amount of time or a short interval of time? Large amount of force acting for a short interval of time. Understand? Large amount of force is acting for a short interval of time. Then that is called as what we used to call? Is called impulsive force. Okay, so this impulsive force always will hurt or not for us. If we'll try to hit anything with a very fraction of seconds, then what will happen? It will hurt or not for us? Yes, please. Hello, can you hear me?
Yes, sir.
Yes, that is what. So that is only called as impulsive force. Now, the product of this force and the time during which the force is acting, that is only we used to call as impulse. Understand? So if you multiply this applied force along with that short time interval, then that is only we used to call as, what we used to call, guys? What we used to call? Impulse, we used to say. Sorry, IMPLUSE. Impulse, we used to say that. Please note it down. Impulse. So what do you mean by impulse? The force applied in that given short interval of time is only we used to call it as impulse. Write the theoretical definition also. The product of force and time, the product of force and time, during which the force acts is called time during which the force acts. Time during which the force acts is called impulse. So impulse means what? By this time you might be understand. What do you mean by impulse? Impulse means force is multiplied with what, guys? Force is multiplied with what? Time interval. Understand? That short time interval. So whatever the force you are applying within that short time interval, if we multiply the two, then we are going to get what? Impulse equals to force into time. Now by this time you can understand what do you mean by impulse. Impulse is equals to product of three. My voice is breaking, Hari? Okay. Now you can hear, I think. Now force means we already know from Newton.